Hello everyone and welcome back to the course. In today's lesson we are going to carry on talking about roots of polynomials, but we are going to focus in the case in which the roots are complex numbers. Let us consider the polynomial p of x equals x squared plus 2x plus 2. If we use the quadratic formula, we have that the roots of this polynomial are given by the following expression. Minus 2 plus minus the square root of 4 minus 4 times 1 times 2 divided by 2. If we simplify this expression, we get minus 1 plus minus the square root of negative 1. If we are limiting ourselves in the field of real numbers, we don't have any solutions for this polynomial, meaning this polynomial does not have roots. But if we extend this field to the field of imaginary numbers or complex numbers, then this polynomial has two roots. The first one, minus 1 plus the square root of negative 1, and minus 1 minus the square root of negative 1. And if we express the square root of negative 1 by the letter I, then the solutions are minus 1 plus I and minus 1 minus I. For being more precise, we define the imaginary number I equals the square root of negative 1 as a number such that I squared is equal to negative 1. In general, a complex number is an expression z equals a plus bi, where a and b are real numbers. We say that a represents the real part of the complex number, whereas b represents the imaginary part of the complex number. One important thing about complex number that is related to polynomials is the following result, known as the fundamental theorem of algebra. If p of x is a polynomial of degree n in the field of complex numbers, then p of x has exactly n roots. As we saw in the previous example, the polynomial x squared plus 2x plus 2 was a polynomial of degree 2 with exactly 2 roots. Let us consider this other example. The polynomial p of x equals x cubed plus 6x squared plus 10x. This polynomial can be factored as x times x squared plus 6x plus 10. Let us find out the roots of the quadratic polynomial in the polynomial p of x. Now, by using the quadratic formula, we get the expression minus 6 plus minus the square root of 36 minus 40 divided by 2, which can be expressed as minus 6 plus minus 2i divided by 2. And if we simplify, we get minus 3 plus minus I. Thus, the roots of p of x are 0, negative 3 plus I, and negative 3 minus I. One real and two complex roots. Something that we can notice from the previous examples is that if z equals a plus b times I represented a root of a polynomial, then the expression a minus bi was also a root of the polynomial. This is actually a general statement, but before establishing it, let us dive into the concept of the conjugate of a complex number. The conjugate of a complex number z equals a plus bi is the complex number a minus bi. Now, the general statement that we were talking about is the following. If p of x is a polynomial such that a plus bi is a root of this polynomial, then its conjugate is also a root of this polynomial. Now, let us take into advantage the fact that we are defining math operations on complex numbers, and let us start talking about basic operations on complex numbers. The addition of two complex numbers, a plus bi plus c plus di, will be equal to a plus c plus b plus d times I. The subtraction of two complex numbers, a plus bi minus c plus di, will be equal to a minus c plus b minus d times I. Now, the product of two complex numbers, a plus bi times c plus di, is performed by doing distributive property. So we get a times c plus ad times I plus bc times I plus bd times I squared. But remember that I squared is equal to -1. So we end up having the expression a times c minus bd plus a times d plus b times c times I. Now, division of complex numbers, a plus bi divided by c plus di, is performed by multiplying and dividing by the conjugate of the denominator, meaning a plus bi divided by c plus di times c minus di divided by c minus di. So we need to perform two products of complex number, one in the numerator and one in the denominator. So we get the expression a times c plus b times d plus b times c minus ad times I divided by c squared plus d squared. Well, guys, it is time to put your knowledge into practice by solving the following types of problems. In the first one, you are going to find all of the roots of the given polynomial, both reals and complex. And in the second type of problem, you are going to perform all of the basic operations related to complex numbers given in this lesson. And as always, see you in the next lesson.